So today we're going to look at what it means to nonlinear SVM. So linear, you know, is a straight line. Look at that example. You can see if I cut a line here, I'm going to split the two classes, right, with a fairly good margin. The name of the so-called support vector, those two points you can see is the support point, the closest point, right, in the training example. So you can see that line is just to bisect these two. Easy to understand. But look at that example. The color, I'm not sure. Oh, my eye is not good. See, the red color is in the outside of this curve, and the black point, is that black? It's very hard to see. Those are another group of points. Let me see if I can get a little better. Oh yeah, I can see the color. If I choose the pen, I'm not sure if I can now draw it. This is what. So you can have two types. I need to go back to the, okay. Oh, that'll help me get it back. Look, this group of points is inside. Now you can see it clear. If you try to put any line, probably you're not going to separate them. So you have the group. This curve more or less looks like a parabola, right? Like a y equals x squared. And those curves could separate them from the outside and the inside. If you make a transformation, that means you do a map for the x vectors to like x squared. Then you make this like a quadratic. You might make this curve as a straight line. That's the whole idea. And then you're going to separate again by the straight line. One side is one class, the other side is another class. Simple idea. But this is very frequent. You have this situation. Cannot be separated by a line. You can separate by a curve. Usually not a too high dimensional curve. So in the previous linear SVM, you remember the dot product. By this time, I really want you to get the intuitive understanding of the dot product. What the dot product show you if I give you two vectors, dot another vector, and you learned in the calculus, right? In the Cal 3, Cal 2, you always use dot product, right? If I make a two-unit vector, make the length of the vector O equal 1, that dot product is exactly the cosine. Are you with me? You remember the cosine distance? The cosine distance measures the similarity, right? If the cosine equal 1, that means they're parallel, right? The biggest cosine is the more similar. If cosine equals 0, you know it's perpendicular, right? They're very different. Are you with me? These two vectors. The similarity is measured in this way because they are unit vector about the proportion, or say direction. So the dot product is really a way to measure the similarity in the normalized way. If your vector normalized like a unit divided by the unit length. So it's a very powerful tool. That's how in your computation, we want to minimize this marginal, which is the dot product, and minimize the marginal means maximize separate them, means maximize the distance. Make sense? And that's the whole idea. But today, all we need to do is change this x by a transformation. Transformation is everywhere. Trans means change. Form means change the form. You remember in my mathematics modeling, the simulation, the first thing, when I talk about a matrix, I'm talking about a transformation. A linear transformation is nothing more than you multiply a matrix. A quadratic transformation is nothing more than two matrices. You multiply them. So, to change the shape. Some transformation, like the projection, can reduce the dimension. You know, if I'm in a 3D guy, you look at my shadow, that's 2D, right? That's a pretty fundamental skill for you to reduce dimensional, like a so-called PCA, grammar component analysis, that you figure out how you're going to reduce the space, keep the most important factor into your model. And this transformation is pretty standard. There's not many different ways. What are these guys doing? Oh.
It has a mind of its own.
Huh?
Turning around and tired 350.
Yeah.
He's trying to.
And we reset it.
It's gone insane.
Yeah. He got a dizzy, man. Okay, now. Sometimes just need to reset. Okay, you got the wrong signal. Maybe the voice, they trace the voice, bounce back and forth. So this transformation, don't worry too much. They're going to do a few ways. There's not many different transformations work very well. That means I'm going to change this thing into that line. That's what the transformation is doing. Typically, it's going to introduce more variables, could be, and make the x to the new variable v. Because it's nonlinear, your transformation typically is not linear. The most frequently used transformation is called RBF, radial-based function. And do you look familiar? What that function is? E to that power over this looks familiar? So of course. And this guy just have too many names. Yes?
Sort of looks like standard deviation.
Yeah, of course it is. You know, this kernel is called the Gauss kernel, heat kernel. You know, if you do the integral, it's the Euler integral, and the error function, just name it. This is just too much use. And of course, you look at this, then you remember what it is, right? It's a Gauss normal distribution. And all the giant looked at those functions before, because it's a phenomenon. Look at a set of data like this. You know, see, radial, you see the radial. Those are the distance shorter. And in the inner circle, this is in the ring after this circle, before this circle, right? And if you want to separate this, you need a circle to separate it, right? That's of course not a straight line. But if I insist on, by the supporting vector machine, get a plane to separate them, so what you're going to do? Well, that's a very easy job. You just lift it up in a way according to the distance, reversed. Can you see it? In the middle is high, because this function, you see, if you're in the mean, that will be 0. E to the 0 is the maximum, right? The bigger you away from the center, and the e to the negative of those will be smaller. Can you see it? It's going to be lower down. That's why you get the normal distribution. In another word, most will be centralized in this mean, right? And now, if you cut this plane, just cut it, you can see when you cut this circular, what I call it, normal distribution, you can cut an ellipse, right? If you even cutter, you can cut a circle, right? So that you can get a plane to separate the two pieces. One is inside, one is outside. Again, this is a linear separate. Can you see it? That's the whole idea. That's the most frequent use transformation. It's called the BF. That's the one most frequently used one. If you select the nonlinear, you always basically, if you don't specify, this is the default setting of SVM. This is the default choice.